So good morning, guys. Welcome to my channel, Dr. Hadeep Kaur, where I'm going to tell you about the stereochemistry. In stereochemistry, we have done so many different type of things, like we have talked about optical activity, enantiomers, diastereomers, and what is the basic behind the stereochemistry. And most important thing that we have learned in the previous video, that we can show different type of isomerism in different compounds. It can be chain isomer, they can be a uh, position, functional, optical isomers, cis and trans, etc. In this particular video, I will talk about RS configuration. That how we can talk that this compound is R or having S configuration. For that, I must say one thing that everyone should know, that we can explain this Rn configuration by some different rules that I will discuss in my coming video. So I want that you should go for further. First watch this video, then you can start another one. Thank you so much. So let's tune to my video. I'll let you know how to do the configuration. Thank you. So as I was talking about, that we will talk about RN as configuration. So let's go for the further discussion. That is how we can assign the configuration R and S to the given compound. So basically, before starting RS configuration, you should know about what is absolute configuration. Absolute configuration, that configuration is self-consistent configuration of enantiomers or asymmetric carbon atom without any reference or correlation to the known or the standard one. So that is a particular configuration that is related to itself, not related to some others. So you can say the exact spatial arrangement of four different atoms or group of atoms about the asymmetric atom, that is called absolute configuration, that cannot be changed, like R, S, is trans, that is absolute configuration. But to specify the absolute configuration in asymmetric carbon, the most common method is R and S configuration. So we will go further. So in which I must say this, that this configuration was given by some scientists like Khan, Ingold, and Prelow. Here, if you will say, I was talking about R and S. This R letter means rectus, and it is right-handed, means clockwise direction. But in case of S, that is sinister, that is left-handed and anti-clockwise direction. What are we talking about? What is left and what is right? So in which we will talk about that how we got to know that it is a R configuration or S. For this, some sort of rules are there. That rules we will discuss one by one. The first rule we have to check, is there any asymmetric carbon? And if it is there is asymmetric carbon, then you have to make it a steric. And what is asymmetric carbon or the chiral carbon, which having four different groups attached to it. After that, you have to assign the priority. You have to give the priority because four different groups are attached to it. So these four different groups have priority according to their atomic masses or atomic number. So that I'll let you know. So after that, you have to arrange all the four different groups, keeping low priority group below or the top of the, means top or bottom of that particular content, if should be there. So, and after that, when you will, see the molecule from the side opposite to the lowest priority group, then you have to check whether the priority is going towards the right hand side or it is going towards the left hand side. Means, is it clockwise or anti-clockwise direction? So first of all, that I'm talking about the priority rules that you have to give in the compound. That the first group is you have to check the priority. Like suppose this is a particular carbon, the chiral carbon, four groups are attached, like hydrogen, chlorine, carbon, bromine. So you know that this bromine is having higher priority. then chlorine, then carbon, at least this is at the lowest priority group. So this is how we can arrange the, this is going to like this. The clockwise, this is having R configuration because H is at the back, top or bottom. So second is, if suppose there are isotopes are attached to that particular compound, like hydrogen or deuterium, in that deuterium will get the higher priority. Similarly, in the case of chlorine. Suppose sometime it can happen that the atom which are attached to that will have higher priority according to the key atoms like CH2, CH3, CH3. So obviously this will have more priority. It's a ethyl group and it is a methyl group. Here both ethyl and methyl groups having carbon atoms, definitely carbon, hydrogen, hydrogen, then hydrogen, hydrogen, hydrogen with atomic number 12, 1, 1 and 1, 1, 1 respectively. So in this case, carbon is attached to two hydrogen and then another carbon, but here this one. This will have the more priority. So sometimes it can happen that the longer carbon chain will attach to the final group will get the more priority because bromine is having higher atomic number than the chlorine. So sometime it can happen that multiple bonded atoms are equivalent to multiple number of attachment by a single bonds. So that you have to also learn by this. There is a double bond, there is a double bond, triple bond, double bond, but what type of the attachment is there? Here, they are attaching with the carbon, 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 hydrogen. Is there carbon, 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 or oxygen, oxygen, and hydrogen? Then nitrogen, 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 like this. Three nitrogens are attached, two oxygen, one hydrogen, one hydrogen, one carbon, like this. So there are three carbon. So you have to check the priority to whom we can give the priority. In this example, this carbon is attached to two ethyl groups and there's a double bond. But this is more groups are attached to this. Longer carbon chain. Another example is same. Longer maximum number of carbon atoms there, they will get the higher priority. So on the basis of all these above rules, configuration in which the priority of the atoms or the groups 1 to 3 decreases in clockwise direction, then you will say it is a R isomer. Or if it is in a anti-clockwise, then you will say it is a S isomer or configuration. So let's take one example. So this is a Fisher projection formula and which is very important to learn. I'll let you know here. So here if you will see A, B, C and D. Okay. So in the Fisher projection, D is the left hand side. Okay, D is the left hand side. So to bring the D at the bottom means A, B, C, D means D is the lowest priority group. I'm just taking the example A, B, C, D. D is having the lower priority group, but it is not at the bottom or the top. So we have to rotate the molecule like this so that D can be go to the top or bottom position. Now, if suppose without any, if I'll say this, that without any example, I'll take this one example in which suppose A, B, C, D. Here A is having first priority, second priority, third priority, and this is the fourth. So 1, 2, 3. This is R configuration. But in this case, A, B, C like this. This is anti-clockwise. Why? Why we are not taking R configuration? It is S configuration because it was S configuration. This is R configuration. So S should be there for this compound. But why it is not? Because if the lower priority group is not at the above or bottom, then you have to change it, rotate it, and you have to, you know, check the clockwise or anti-clockwise direction. I'll take one example, lactic acid. In lactic acid, this is the carbon attached to four different groups. Okay. So we have represented our acid like this, suppose. So here, who is having the lowest priority? Hydrogen. So hydrogen will get the fourth number. Very true. Here, and hydrogen will get the fourth number, but who will get the third number? This one. Here, this oxygen is directly attached to this one. So it is first number and second number. So in this case, hydrogen is already, lowest protein group is already on the top or the bottom. So whatever the confusion we are going to, 1, 2, 3, it is R configuration. But in this case, if it is been this side, then how you will, this is first, then second, this is fourth and third. This is this side. So it is S configuration. So you can check this also. This in this particular video, different different examples I have given, and you can just correlate and explain. Hydrogen is on the lowest protein group here. So if you will get it, this is the lowest protein group. At the bottom, it is fine. Whatever the here it is clockwise, it is. You will get all this. You will practice this example at home. This is another example. You can pause this video and just try it at your home. Okay. 1 chloro, 1 bromo, ethane. These different examples I am giving so that you can correlate them and check it how it can be possible. Tartaric acid. This is a table where you will get to know what type of the groups are attached, 4 different groups, and atomic number of the first one, and what are the different atoms which are attached to the first one, and then the priority which was given to the groups. This height. Take this, post this video, and you can try this also. Okay. Now, if you want to assign the configuration, suppose R and S to the given compound, suppose this one, here you can see that hydrogen, which is having lowest priority group, and then you can have this on the right side. But according to the rule, it should be on the fourth position, but it is not on the fourth position. Order of priority, if I'll give it the first to the OH, second to this one, and third to this one. According to this, it is 1 to this side. Means it should be S. But I have already told you, you have to make some changes in the compound. You have to rotate it or exchange the groups so that this hydrogen should be at the bottom position. So now if it is now at the bottom position, then you will check the priority first, second, third, and fourth. First, second, third. It is R. Previously it was S, but you have to write it R. Correct answer is R. Okay. Why? Because lowest priority, whatever the lowest priority group is present, which is attached to the chiral carbon, it should be on the below or the above, top or bottom of the Fisher projection formula. Similarly, if you will see here, in the second example, here hydrogen is at the bottom. Fine. This is the first, okay, and then COH having the second. This is having third. Why COH having second priority rather than CH2? Because here carbon is attached to two hydrogen, but here carbon is attached to oxygen. So this is having more priority. According to this, it should be If you will exchange it or you will keep it at the bottom, then you can check. Sorry, first, then second, then third and fourth. It is R. Why in both cases it's R? Because I have already told you the rule is lowest priority group should be bottom or the top, then it is fine. It will be same R, R. Its configuration is R. So you will take this moment and have this example at your home, and you can explain it by round why it should be R or should not be R. Okay. Now, so now the question is, suppose in your exams you are getting some questions, and it is very important to explain it, that why people are talking more about the configuration like R and S. So in that particular case, we will take some examples, and in that example, we will talk about something, that how to check this. So let me do. So suppose question is, find R and S configuration in the following compound. Okay, so I'll get very beautiful compounds. 1, 2, 3, 4. So let's start with the first compound. This first question is, you have to check first that where is the lowest priority group. It is on the left side, but it should not, it should be on the top or the bottom. So, okay, I can give the, suppose I will give the priority, character priority 1, 2, 3, and 4. According to the rule, its configuration should be S, whatever the priority group. But because H is not at the bottom, we have to exchange this. Because of that, you will get the R configuration. So let's have this. Okay, so whatever I had told you, I have already explained it here. Because the clockwise orientation, but lowest priority group is on the horizontal line, and its configuration is R, whatever we have talked in this example. Same. So similarly, we can go for this also. 1, 2, 3, 4. It should be 1, 2, 3. Here it is R, but lowest priority group is not at the bottom, so it should be S. Now you can check the answer. Yes. In this case, rotation is here clockwise, so it should be R, but it should not. Why? Because lowest priority group is on the horizontal line, and we have to make it on the vertical line. So configuration answer is S. So we are correctly. So similarly, you can go for this example also. Whatever, you can post this video and explain it at home, that why it is so. It should be S, but why it is R? Because of the lowest priority group is not at the bottom position. Very interesting. So what will happen? Suppose if you are having two chiral center in a one example. Which chiral center? I'm talking about this one and this one. Both are, this is the chiral center 1 and this is the chiral center 2. Now the question is, we have to check the both chiral centers priority, and we have to give the last configuration. Okay. Now what we will do first, if I'll say nitrogen will get higher priority, then this carbon attached, which is oxygen, and then this one third one, whatever the group, the whole group is attached here. This is the fourth one. Now it is 1, 2, 3. It is S. But because this hydrogen is on the horizontal line, it should be on the vertical plane. So that's why R, S should not be there. It should be R. Answer you can check even. Yes, R. Similarly, if I'll check for the second, we have done with the first one. Now we have checking the, here is also, this oxygen will get first one, second priority, third. So it is like 1, 2, 3. It is also Antichloride, it should be S, but hydrogen is not at the bottom, so it is getting R. So the whole compound here will get the configuration R. So this is how we can, give the configuration. These are the another examples with the different presentation of three-dimensional structure of that particular compound. Here you have seen this hydrogen is far away, fluorine is near the observer. In this type of case, in these type of the structures, you have to check not top and bottom. You have to check away from the on the dotted line. The lowest protein group should be there. So I'll take one example here. Here, fluorine, chlorine, bromine, and iodine. So here it is bromine, iodine is getting first number, fluorine is getting, bromine is getting second number, and fluorine is getting third number. So it is like 1, 2, 3. It is anti-clockwise. So that's why configuration is S. Is it S or it should be R? No, it should be S because hydrogen is already away from the observer. If it is on the dotted line like this, then it is away. So whatever you will get, that will be your answer. But here, if I'll take the bromine will get the first number, chlorine will get the second number, this one will having third number and fourth number. This according to normal rules, one, two, three, it should be S configuration. But why it is not S? Because hydrogen is not at the dotted lines. So it should be exchanged and your answer should be R. It's very easy. If you will take these tricks and apply it, you will never be failed to give the assigned configuration to R and S to the three-dimensional compound. So here it is this. Now the question is, in this example, we can give the R and S configuration? Okay, let's check. S is one number, second number. Oh, to whom I give the third and fourth? Because both are the same. There is not a chiral center. This molecule is not a symmetric center. It is not attached to four different groups. So we will say neither R nor S. This molecule is achiral. So only chiral molecules can be designated as R and S configuration.